All right, let's dive right in. Today, we're tackling one of the biggest challenges, and honestly, one of the biggest mysteries in India's massive push for clean energy. It's a story about huge ambitions, a seriously powerful solution, and a puzzle that involves a whopping 92 gigawatts of missing power. Let's get into it.
So, this is the big question, right? It's at the very heart of the global energy transition. And for a country like India, with its energy demand just shooting through the roof, this isn't some academic problem. No, this is about national security and economic growth. Solar and wind are amazing, but they're not always on. So what happens in the gaps?
Now, to really get a sense of the scale we're talking about, you only need to remember one number: 500 gigawatts. That's the massive goal India has set for its non-fossil fuel energy capacity by 2030. Hitting a target that huge means you've got to figure out how to weave all that variable renewable energy into the grid without it collapsing. Solving that intermittency problem, it's absolutely essential.
So, how do you do it? Well, the answer is actually pretty cool, and it's been hiding in plain sight for decades. It's something many people are calling India's giant water battery.
You know, the idea is just brilliant because it's so simple. It's called pumped hydro storage, or PHS. When you've got extra solar or wind power, say in the middle of the day, you use that cheap electricity to pump water from a low reservoir up to a higher one. Then, later, when everyone gets home and turns on their lights and the sun is set, you just let that water flow back down through turbines, generating power. It's literally a giant rechargeable battery, perfect for providing power for 6, 8, even 10 hours straight.
Okay, so this is where things get really interesting. This brings us to the core of our story today, a massive paradox, a real mystery, if you will, about a whole lot of missing power that could be making India's grid rock solid.
And that's the question we have to ask. I mean, with a solution that's such a perfect fit for India's needs, a proven long-term storage technology, you think you'd see these water batteries popping up all over the place. But you don't. And that right there is the paradox.
So just how big is the potential here? Well, according to the Central Electricity Authority, India is sitting on over 96 gigawatts of potential PHS capacity. That is a staggering amount of storage, way more than enough to anchor its clean energy future.
But the reality on the ground? It's just 3.3 gigawatts. Yeah, you heard that right. Out of a potential of nearly 97 gigs, that's all that's actually working in pumping mode. That leaves this mind-boggling 92 gigawatt gap between what's possible and what's real. So what on earth is stopping these things from getting built?
To solve this mystery, we've got to play detective and look at the culprits holding these projects back, because it really is a race against time to get this power online before that 2030 deadline.
All right, culprit number one is just time. Building one of these PHS plants is a marathon, not a sprint. We're talking 6 to 8 years from the first idea to actually flipping the switch. You've got long waits for land, all the environmental permits, and then the construction itself. That long wait, it makes investors really, really nervous.
And that nervousness leads us straight to culprit number two, commercial risk. Get this, almost 4 gigawatts of projects that were already awarded were canceled, just scrapped. Why? Because the developers couldn't get the local utilities to sign long-term contracts to buy the power. The utilities are basically thinking, hey, by the time your plant is built 8 years from now, what if some other technology is cheaper? And that other technology they're usually looking at? It's battery energy storage systems, or BESS. Now, batteries are awesome. They're super fast to build, but they're best for short bursts of power, 2 to 4 hours. PHS, on the other hand, it's slower to build, but it is the undisputed champ for the long-duration heavy lifting that India needs to power through the night. They're not really rivals. They're more like partners with different jobs.
So, if time, cost, and risk are the big problems, how do you fix it? Well, our investigation has led us to a genuine breakthrough, a much smarter way to build these water batteries.
It's called Off-River Pumped Hydro, or ORPH for short. And the idea is simple. Instead of building a big dam on a major river, you build 2 separate, self-contained reservoirs. These closed-loop systems only need to be filled with water once. It sounds like a small tweak, but this little design change has absolutely massive implications.
And here is why this is a total game changer. First off, by not being on a major river, you completely sidestep those messy, decades-old water-sharing disputes between states. Huge win. It's also less vulnerable to climate change stuff, like droughts, and it's generally a lot easier and faster to get the environmental clearances. And the big one? It's cheaper to build. It's the perfect example of a clever engineering fix for big political and financial headaches. I mean, the numbers really tell the whole story here. A traditional on-river project costs about 6 crore rupees per megawatt. That's well above what's considered financially viable. But look at Off-River PHS. It comes in at around 4 crore, hitting that sweet spot. This is the key. This is what makes private investors sit up and say, okay, now we can talk.
So we have the better technology. We have the breakthrough. But as we all know, technology by itself is never enough. We need a clear, actionable roadmap to make this happen all across the country.
And here it is, the policy toolkit to unlock this whole thing. We need to speed up the approvals, maybe with a single window system. States need to get the land ready before projects are even bid out. But the most critical part, the thing that changes everything, is how these plants make money. We have to guarantee them revenue just for being available, and we need to pay them for all the little things they do to keep the grid stable. That's how you take the risk out of it for developers.
So this is about moving way beyond the old model of just buy low, sell high. Think about it. If you want someone to invest in a project that's going to last for 40 years, you've got to give them some certainty. That's what these capacity charges do. It's like a retainer fee, paying them just to be on standby, ready to go. It provides that long-term security that the market absolutely needs to build these things.
And we need it now, because the clock is seriously ticking. The government's own official plan calls for nearly 19 gigawatts of this stuff to be up and running by 2030. That means all the studies and all the debates, they need to be over. It's time to build.
So there you have it. We started with a massive energy problem, we found a powerful solution with the water battery, we investigated the mystery of why it wasn't being built, and we uncovered the breakthrough with the off-river design. The tech is there, the policy roadmap is clear. The key to solving that 92 gigawatt paradox is right here in our hands. The only real question left is, will it be turned in time? Thanks for joining this explainer.